His presenter is Maxime Noël, and his topic is DynamoDB and DynamoDB-Mapper Building Scalable Python Applications with Amazon's NoSQL Database. Okay, welcome.
Testing, testing. Is this thing on? Can you guys hear me? Okay, hello Python community. My name is Max, and I work at Ludia. We make Facebook games. And I'm here to talk to you about Amazon DynamoDB. So, first things first, have any of you guys ever heard about DynamoDB? Do you know what it is? Yeah, some of you do? Okay, so quickly, yeah, it's Amazon's NoSQL database. It's a hosted service rather than actual software you install on one of your computers. And it's pretty recent. It was introduced in, I think it was January this year. So, as a NoSQL database, it is not relational. It is much more fluid than SQL databases in schema definitions. It has, however, a query language that is much simpler and much less powerful than SQL. And, well, as is the case in most NoSQL databases, the emphasis is on performance and scalability rather than features and expressiveness of the language. And it is extremely scalable. So DynamoDB works as a key value store. Its data model is based on tables and items. So items are the local equivalent of SQL rows, which in the case of DynamoDB, you can think of those as Python dictionaries because that's basically what they are. And unlike an SQL database where you have to define for each table every column you need to have and its type and range of allowed values, etc., etc. And you need to run complex migrations whenever you need to add, remove, or modify stuff. DynamoDB doesn't have any of that. Instead, its schemas require a primary key. You need to tell DynamoDB when you're creating a table whether you want your table to address items with simple primary keys, like one attribute, which is called the hash key, and it's exactly the same thing as keys in a Python dictionary. Or if you want to have a composite primary key, which is based of two components, a hash key and a range key. You can basically think of those as a folder hierarchy in a file system. So the hash keys still work kind of like keys in a Python dictionary. They are not ordered. And within one given hash key, you can have as many range keys as you want. And those, however, are ordered. They are sorted, which can come in handy for some cases I'll show you in a few minutes. That's all there is to a schema declaration. That's it. Every field you want in any of your items, everything is optional. You can add what you want, remove what you want, whenever you want. There are no restrictions. So for example, let's say I want to implement a blogging website using DynamoDB. And yeah, everybody's done blogs, and we've got tons of those, but we don't have any with DynamoDB itself. So I'd make a user table that would use a simple hash key, which is called ID here. You can see it in the deck examples on the left, and then a blog post table, which would be using a composite key. So the hash key would be the user ID, and the range key the date. There is an operation in DynamoDB called query, which allows you to, for example, get all the items with a given hash key and disregard the range key. So you can use it to retrieve all the blog posts by one user, as you can see there. Once again, other than the primary keys, so ID or user ID plus date, the other fields are optional. You can add them or remove them as you want. So yeah, I'm here to talk to you about DynamoDB because it rocks. It is awesome for a lot of reasons. One of them is that it is entirely managed by Amazon. You don't have to install any specific servers on your machines. So it's all in the cloud. So the cool thing about that is that if you want to actually deploy one of your projects in production, the entire setup time is 1 minute per table, and that's it. It's working there is almost no downtime because it's all managed by Amazon and they know their stuff most of the time. And the really cool thing is that it scales with money. Yep, that's your dream come true, because every operation in DynamoDB has predictable performance, because there isn't a lot of those, and each of these operations costs a number of read or write units. And yeah, if you want more read units per second, you just have to pay more and they'll give you that. And yeah, you can get to pretty high traffics without having to ask anything specific out of Amazon, except, yeah, take more money from me. The obvious related downside is that it can be fairly expensive. So read and write units are basically when you want to write an item, so a row in a DynamoDB table, it costs one write unit and it costs one read unit to read it back. So those are the prices for both traffic and storage. So depending on what you want to do, you may find it pretty steep. So I strongly recommend actually against it if you're just building small-scale personal projects like a blog, for example. But and yeah, if you're ready to sacrifice the consistency of your data, so if you're ready to read data that's a few seconds out of date, you can actually double your read units with a feature that's called eventual consistency. Otherwise, you just specify strong consistency everywhere and pay a little bit more. The underlying access protocol is HTTPS. You actually access DynamoDB with a library called Boto, which is the lib you use to access most of Amazon services in Python. So yeah, the protocol is simple, it's stateless, it has no bizarre black magic with like stack introspection, like SQL alchemy or whatever. And it's all pure Python code, so it runs wherever you can install and run Python. However, DynamoDB has a few things that sort of suck. Why does it suck? Well, as I said before, there are only two schema types, which are very simple, but for example, if you need a composite key with more than 2 elements, you're out of luck. It's not supported out of the box. You need to hack around it. Also, you need to specify the keys of the items you create. So if you want something like an auto-incrementing key, it doesn't exist. You have to find a way to roll out your own. And it is not relational at all. Each table exists in its own separate universe, per se. So there is no guaranteed integrity of keys between tables. If you reference a key of one item in an item of another table, you have to make sure it stays consistent yourself. Also, the query language is extremely simple, by which I mean there are only 5 operations. Get, put, and delete, obviously, read, create, write, or delete one item whose entire primary key you need to explicitly specify. You have query that allows you to do something that's a little bit more sophisticated in tables with both a range hash and range key. So if you've got a composite key, you need to specify only half of it and maybe a criteria on the rest. But it's still not a general purpose select. The general purpose select is scan, but scan is an extremely expensive operation because it doesn't use any indexes. It basically walks through your entire table, using up read units as it does. But on the other hand, you can specify arbitrary conditions. But it is expensive and slow, and you should not use it unless you really need to, but try to find a way around it. In addition to that, attributes in items can only be of 6 data types: number, string, which is actually a Unicode string, so that's pretty cool, binary blob, number set, string set, or binary set. That's it. Nothing else is supported. So those are sets, not lists. There is no nesting supported. You can't have sets of sets or whatever else. And yeah, if you need dates, times, you're out of luck. It's not supported out of the box. And also, if you want to write an attribute that's an empty string or set, you can't. It's not supported. You need to represent it as a missing attribute. Okay. And again, the low-level Python API is pretty bare bones, and it exposes all those limitations directly. You also have one way to maintain integrity, which is conditional writes. Since the entire protocol is stateless, you have to be extremely careful not to overwrite data that has been written by something else. And that's done with something called conditional write. Basically, it says, write this item if and only if its current attributes are this, that, and that. Otherwise, fail. That's not extremely easy to use. So, of course, we can make it better. We are Python. We are awesome. And we're not going to stand for those petty limitations. We can work around most of them. So let's do it. And at Ludia, we did that. We wrote something called DynamoDB-Mapper, which is an object document mapper for DynamoDB. You can find it on Bitbucket here. It's LGPL3. So, yeah, feel free to use it. Just give modifications back if you make any. You can install it with pip. And first of all, it allows you to work with Python objects rather than raw dicts. So yeah, we totally stole that design from MongoKit because, hey, it works. You just specify, you just create your table, inherit from DynamoDB model, specify the name of the table you want it to be stored in, the name of the hash key, the name of the range key if you want to use one, otherwise just forget it. And then there is the schema that basically says, yeah, I want those attributes in my objects, and I want them to have those particular types. And you can also specify defaults, because, well, it can always be very useful when you're creating tons of stuff. So empty strings and sets are automatically supported. They are still stored in the database itself as missing attributes, but you don't have to see that. From your point of view, they show up as empty strings and sets. The 5 standard operations are supported with, well, all their features, or lack thereof. And we added support for extra data types. So first of all, if you want a hash key that's auto-incrementing, well, as I said, there are a few hacks to make those work. Well, you don't have to write those hacks. We wrote one, it works pretty well, and it's in DynamoDB-Mapper. However, if you can, try to avoid using auto-incrementing keys, because usually you can find a better way to design your application that doesn't require them. Dates and times are also pretty useful to store, so we added support for that too. Internally, inside the database, date times are stored as W3C DTF in UTC, so that's the kind of thing you see there. It's up to microsecond precision. And since this format is actually able to be sorted alphabetically, that also means that date times can be used as range keys. And finally, we added support, well, limited support for lists and dicts, which are basically serialized as JSON in the database itself. It is a hack, I'm aware of that, but it's working pretty well, and we are using it. So, and it even supports limited nesting. I mean, basically anything that you can serialize as a JSON object or array, you can store it inside our DynamoDB with DynamoDB-Mapper. And it's automatically done. We also made conditional writes easier. We shortened the whole thing to a single flag that's called raise_on_conflict, which basically allows you to, either you just created your object, and if you save it with raise_on_conflict, it will make sure that an object with this primary key doesn't exist in the database. So that means if it's going to overwrite anything, it's going to fail. Otherwise, if it's an object you retrieved, you loaded yourself from the database, raise_on_conflict will make sure that it hasn't changed in the database since the last time you accessed it. So yeah, that's how it works in diagram form with a few gritty implementation details. And we also added something called transactions, because most of the time the pattern for a conditional write is get something from the database, modify it, save it, if and only if it hasn't changed, and well, if it has changed, start over. So we made a class that does this in your stead and makes it a little bit easier. You just have to define functions that says, yeah, my transaction is going to modify this and that object. And yeah, it's automatically retried until it's successful. And the cool thing is that a single transaction can target multiple objects, sometimes even in multiple tables. However, they are not SQL transactions. You have no rollback, you have no real atomicity, and no integrity constraints between tables. So for example, if a transaction fails after modifying one object, and it should still modify 2 or 3 extra objects, only the first one will have been modified, and it'll stop at that point. It will, however, tell you that it failed, why and how. But again, if you need complex inter-table transactions with commit rollback semantics and all, stick to an SQL database. Don't use DynamoDB. It's not for you. Again, we stole more stuff from MongoKit because MongoKit works pretty well. So we stole migration from it too, because when you want to make your schema evolve, since the whole notion of a schema is not really in the database itself, you need to run on-demand migration. So yeah, it's defined in the same way as in MongoKit. It's just you define a validator that says, yep, my object matches this version of the schema, and the migrator that allows you to get from version n-1 to version n of your schema. It's run when you're retrieving objects from the database, and it is not an offline migration. Your DB is still up while the migration is running, because it's your program that's actually doing it. So we're using it, DynamoDB and DynamoDB-Mapper, in a multiplayer bingo game, which will be released sometime in the next few months. So it's a Facebook game, high-profile brand with a freemium model. We expect 300,000 daily active users, roughly. So we've got tons of concurrent users, but very low interaction between them. So we've got a REST backend API, and basically one database shared between as many servers as we want. It's all running on Amazon EC2. It's in the cloud. So here's an example of an actual class we have in Bingo. It's the definition of a room. So as you can see, we are using extra data types like lists, because there are cases where ordering is actually important, so we couldn't go with a set. For example, yeah, the energy costs for a card, it costs you 1 ticket to buy 1 card, 2 for 2, etc., etc. Sorry. And we also have references to other IDs of other tables. So for example, dub reward ID is actually an identifier of another object in the rewards table. And here's a transaction, which is the user game result class. So as you can see, it defines both a hash key and a range key, because it's indexed by user and by dates time. Yay, extra data type. Date times are awesome. We use them. And the definition of the transaction is the getTransactors method here, which basically said this transaction first gets a user, modifies it to give it chests, coins, energy, experience, etc. And then, after saving that, it also gets the user's stats, which are yet another table, modify them for just some bookkeeping information, and saves it again. And yeah, that's it. It's a transaction. Woo! I said that. Do you guys have any questions? Do I have any time left?
1 minute.
Okay, I've got 1 minute. Questions?
Are you looking for any contributors to DynamoDB-Mapper?
Yeah, sure thing. Just go on Bitbucket, check out the code, read it. We're open to pull requests, and we've got a bug tracker. Sure. Please contribute. We'd appreciate that.
Can you use the audience mic? Thank you.
Oh, yeah, sorry. The first question, by the way, was, are you looking for contributors? And the answer was, yes, we are.
Do you have any other examples of the transactors there? The way that you've got the list of 2 values that make up the transactions?
I don't have any here right now, but I can talk to you about that afterwards. I had to compress my talk a little bit because of the time. Sorry about that. But yeah, if you want to talk about it after the talk, I'll be here. Don't be afraid. I'm not evil.
But you do Facebook game, though.
Yeah, that's true. I make Facebook games, but I'm not evil. Okay, I think that's all the time we had. Was it?
Yeah, that's it. Thank you.
Okay, well. Well.